I'm trying to find place actually to do a class.
This call is now being recorded.
Sorry. Right. So can you hear my voice clearly? Right. Okay. Okay, so please, Yang and 4K monitor, no, Kelly. Kelly, please take the attendance for today, right? Okay. So where's the last time I think I stopped at, did we already do this exercise? Did we already answer this exercise? Yes. Okay. All right. So means until here, right? Speed and velocity, is it? All right. Thank you. Okay. So speed and velocity. Okay. So what is speed and what is velocity? So what is the difference? Okay. So actually speed and velocity are used to describe, okay, how fast a car is moving. Okay. So this is actually the dashboard, right, in your car. So it will show what is your car velocity, right? And this one is in kilometer per hour. Okay. All right. So how is velocity is different from speed? Okay. Right. So this is the difference between. Okay. So this one you change to speed. Okay. And this one you change to velocity. Okay. All right. So what does it mean by speed? Okay. So speed is the rate of change of distance. Okay. So they use a scalar quantity. Distance is a scalar, right? So they use a scalar quantity. So rate of change of distance. Okay. And then for the unit, okay, is ms negative 1. Okay. That one is for speed. And speed is a derived quantity. Okay. Because you already know the unit for speed is ms negative 1, right? Same. So multiply length and second, right? Length and time. Okay, so you multiply length and time, you use a multiplication, so you will form a derived quantity. Okay, all right. So this one is the derived quantity because consists one more than one unit. Okay, and it's a scalar quantity. Okay, that is a speed. Okay, and then this is the formula. Okay, speed is distance divided by time. Okay, so how about the velocity? Okay, velocity is the rate of change of displacement. Okay, so displacement is actually a vector. Okay, it's a vector. All right, the unit is same, ms negative 1. Okay, and also the velocity is a derived quantity because it consists more than one base quantity and is a vector. So vector means they have a magnitude and direction. Okay, and for this one scalar, they only got a magnitude, so we ignore the direction of the speed. Okay, then how about the formula? Okay, the formula is displacement divided by time. Okay, so this is the difference between speed and velocity. So let's say I give you example. Okay, I give you example. Okay, wait. Okay, wait. My internet is slow here. Okay, right. So let's say I have like this. Okay, A, B, and C. Okay, so let's say the distance from A to B is 3, B to C is 4. Okay, and then AC is 5. Okay, so the first question, let's say find the distance. Okay, from distance from A to C. Okay, so the second from A to C. Okay, so usually distance is a total length, right? So A, B to C. So this is the distance. Okay, So this is distance. Okay. So 3 plus 4. Okay. 3 plus 4. So distance is 3 plus 4. So you got 7. Okay. Then how about displacement? Displacement is the shortest, right? The shortest distance, okay, in the certain direction. So if you want to go from A to C, right? So the shortest distance is actually 5. So displacement is 5 meter. Okay, until then, are you clear? Are you clear? Do you want me to repeat again? Yeah. All right. Okay, and then the third question, okay, they ask you to find the speed. Okay, and we already know okay, and then S is actually if distance they use distant value, right? So 10 seconds. So this is the example only. So let's say the time is 10 seconds. So 7 divided by 10, we get 0.7 ms negative 1. Okay. So this one is for speed. But for displacement, for velocity, okay, then we use a same formula, but the S is actually the okay, what is the displacement here? 5. Okay. Then how about the time? The time is negative 1. Okay, so that is the difference between velocity and speed. Okay, and how you want to calculate them. For the speed, you take a distance, okay, as a S. Okay, and velocity, you take the displacement as S when you want to calculate the value. Okay, and then you have to consider also the direction. Okay, you have to consider the direction also for this for velocity, because you use a displacement, right? So you have to consider the direction, whether it's positive or negative, move forward or move backward. Okay, so you have to include that in the velocity. But for speed, you just ignore the direction. Okay, you just add all the length, the total length, okay, that object travels. Okay, and then you divide by time. Okay, so you don't need to put the positive or negative sign. Okay, but for velocity, you have to consider all the direction. Whether, let's say I have a ball, okay, and I throw it onto the wall. So what will happen? The ball will move towards the wall. Must be positive, the value of velocity. But when it move backward, okay, backward, so it become negative. So you have to consider all that. Okay, the direction. But speed you don't need, just take all the value, all the magnitude, okay, and then you just divide by time. Okay, so are you clear about this one, how to calculate speed and velocity? Anything you want to ask teacher? Make sure you really understand about this. Okay, so next part, we already discussed this one. Okay, so this is the example, the supersonic car. Okay, so the fastest speed on the land is 1220.9 kilometer per hour. Okay, and then this speed is achieved by Andy Green, which drove his supersonic car. Okay, thrust in Rock Desert. Okay, Nevada 1997. So this speed is faster than the speed of sound. So usually the speed of sound is 340 meter per second. Okay, 340 meter per second. So this one is fastest than the speed of sound. Okay, but the speed of light is fastest, because that one is 3 times 10 power of 8, right? But for sound only 340 ms negative 1. So this one is actually for the knowledge. Okay, supersonic car. Okay, and then next one. Okay, so average speed thought is what is the formula for the average speed? Okay, so the average speed is the total distance divided by total time. So you have to know this one, they use a speed, so means they have to use a distance. Okay, and then if velocity means you have to use the total displacement. Okay, total displacement. Okay, because speed is a scalar and distance also is a scalar. Velocity is a vector, displacement also is a vector. Okay, so later we learn how to use this formula, okay, to calculate, okay, the value, right? Okay, next one is a uniform speed. So what is a uniform speed? Okay, so the speed that remain the same in magnitude regardless of its direction. Okay, so let's say if I have a car, okay, I have a car, okay, and it move like 60 meter per second, okay, and then when it move backward, it also move with 60 meter per second. Okay, so this one we call it as a uniform speed because the speed is same. Even the direction is different, okay, but the speed is same. Because speed we don't consider the direction because it's a scalar. So we don't consider about the direction. Okay, as long the magnitude is same. Okay, so this one 60 meter per second, then it move backward. Okay, 60 meter per second also. So this one we still call it as a uniform speed. Okay, but is it still considered as a uniform velocity? Any answer? Is it considered as a uniform velocity? No. Why no? Why no? Yes. Yes. Okay. So if the question asks you if this one is a uniform speed, yes, it's a uniform speed. But if the question asks you, is it uniform velocity? No, because the direction is opposite. It's different. Okay. So you have to consider for speed, you just consider the magnitude. For the velocity, you have to consider the direction. Okay. So that one you have to remember. Okay, speed is a scalar, velocity is a vector, vector must have magnitude and direction. Alright. Okay, so this one uniform velocity, velocity that remains the same in magnitude and also direction. Okay, so let's say if I got 60 ms negative 1, sorry, 60 ms negative 1, okay, and it move in one direction only, this one is a uniform velocity. Okay, okay, so this is called as a uniform velocity, but this one only uniform speed, but uniform velocity, okay, it's not a uniform velocity. Okay, so for this one, I want you to try, okay, I want you to try for this one. You have to find the average speed, okay, so average speed is, what is the formula? Total speed, right? So speed must use this distance. Okay. Total distance divide by total time. Okay. Right. So try to calculate the V. Yeah. Make sure you understand, right? If you don't understand, please ask teacher. Ten point 44 ms negative 1. Okay. Any other answer than 10.44 ms negative 1? Any other answer? Okay. So for those who are just quiet, didn't respond me at all. So later when we get a questions, I will call your name. Okay. So don't be quiet like that. Please respond. You can chat. You can open your mic to talk. Okay. I will ask because this one is still considered as your PBD. Okay. And all your message here will be recorded. Okay. So this one is 100 divide by 9.58. So you will get 10.44 ms negative 1. Okay, so this is the answer for this question. Right. Okay, next one. An object has a non-uniform velocity if the magnitude of its velocity change and also the direction of the motion change, or the motion is not in a straight line. So maybe it move in a curved line, right? In a curved line, so we cannot say that it move in a non-uniform, sorry, we cannot say it move in a uniform velocity. So you have to remember two condition for an object. Okay, if you want to say it move in a uniform velocity, okay, the magnitude must be same, okay, and then the direction also must be same, okay, and it move in a straight line. So that's the condition, okay, for an object if you want to call it is move with a uniform velocity. Okay, you have to consider the magnitude and also the direction. Okay, but if you want to say uniform speed, okay, you just need to consider its magnitude only. Means if you move in 60 meter per second, so all the way it will move in 60 meter per second. There will be no change in velocity, right? Okay, so that's how, right? So like this one, okay, so I will let you answer first, okay, and I will call someone, okay. So maybe one person I will call in the choosing from the name list, okay. So answer first for this one, number two, okay. So is the speed of both cars same? Is the velocity of both cars same? Okay, don't answer in the chat room. Okay, I will choose who will answer this question. Okay, I give you 2 minutes to answer. Then I will call name. Okay, if you don't understand anything, okay, teacher really hope then you can ask me, okay? Please ask teacher. Okay, because I don't know how long we'll be online class like this. Okay. It's just even like this one, the chapter is quite easy, okay. But if you don't understand, please to ask, okay. Especially for those who just quiet in the group, don't ask anything, okay. So please ask. Okay. So I choose, right? Sorry. I will choose one of you to answer. Wait. Hmm. Hmm. Correctly, the you. Or you can open your mic. I want to know the answer for the first part. Is the speed of both cars same? I just want to answer you to answer for this one. Is the speed of both cars same? No mic. Okay, then you have to write your answer in the chat. So what is your answer? Is the speed is same? Same, right? Why? Why is same? Because different direction. So speed is same because it has a different direction. Okay. All right. So the answer is correct, is same. Okay, but the reason for the answer why is same, okay, is not correct. Okay, okay, it's okay, good try. Okay, so the speed is same because speed is a scalar quantity. Means it's only consider the magnitude. And it's already said that the car travels, okay, from north is 80 kilometer and another car travel 80 kilometer towards south is 80 kilometer. So you can see both have the same magnitude. Okay, and speed is a scalar, right? So mean it doesn't consider the direction. Okay, as long the magnitude is same, both is 80, right? So means it's same. Okay, so speed is same because it's a scalar quantity, right? So are you clear? You clear, right? So it's not because it have a different direction, it's because they have a same magnitude. Okay, both is 80. So that's why we call it as the same speed, right? Okay, next one. Okay, I will call Chin Wai Hong. Okay, Chin Wai Hong. Right, so Chin Wai Hong, what is the answer for the second questions? Is the velocity of both cars same?
Yes.
Yes, velocity is same. Okay, why? Why is same? Why is same? Hmm. Why is it is same for velocity? Why is same? Because despite traveling in opposite direction, the speed is still same. They're making the same velocity. Alright. Okay. Alright. Okay, let me tell you one thing. Okay, seems you still not so clear about velocity and speed. Okay. Okay, if I have two balls, okay, two balls, okay, ball A and ball B. Okay, ball A and ball B. So the ball A move to the left, okay, with 30 meter per second. Okay, and ball B, okay, it move 30 meter per second, okay, in left to the left, okay, to the left. Okay, so if the question asks you the first one, is it the speed is same? Okay, right? Right. So they say the first one is said, is it the speed is same? Speed is same. Second one, velocity is same. Alright. Okay. So speed is what? Speed is distance divided by time. Okay. So distance is a scalar. Okay. So scalar means they only consider a magnitude, means the value of the speed. So this one both move with 30, right? It move with 30. So means the speed is same. Okay. Speed, we didn't consider the direction. We only consider the value of the speed here. Okay, so the value is actually the magnitude. So So if the question asks, speed is same for ball A and ball B, yes. Why? Because the magnitude of the speed is same, 30. Are you clear? Are you clear about that? Okay. And then second one, when they ask you whether velocity is same. Velocity is displacement divided by time. Okay. So when it use displacement, it means it has to consider the direction and also the magnitude. Okay. They have to consider the direction and the magnitude. Okay. Since it's vector. Okay, so you can see here, is it the direction is same for ball A and ball B? No, right? One move to the left and another one move to the right. So means the direction is different. So when the direction is different, so displacement also will be different. Okay, so the velocity is not same. So if the question asks you why, because it has a different direction, or you can say they have a opposite direction. Okay, so are you clear about that? Teacher, does uniform speed means the object stationary? No, it's moving but in the same magnitude. Let's say if I say I drive a car 50 ms negative 1, okay, so means in uniform velocity, sorry, uniform speed means I drive 50 meter per second. So let's say this one. Okay, good question. So let's say I drive 50 meter per second for 5 minutes in uniform uniform speed. So means in 5 minutes, okay, I drive with 50 meter per second, alright? Means the value of my speed does not change for 5 minutes. Okay, if the object sits stationary, then the value the speed is 0. That means the object is not moving. Okay, alright. Okay, so for this one, to answer for this one, Wai Hong, are you clear why I said the velocity is not same? Wai Hong, Chin Wai Hong. I'm not sure whether did you open your mic? No, right? Okay. So do you understand why I said the velocity is different? You want to speak to me? Yes. Wait, yeah. Paper 3. Okay. Right. Okay. So any question you want to ask? Okay. So for this one, okay, the answer is speed is same because it has the same magnitude. Okay. But for velocity, it's not same because it's travel in the opposite direction. Okay, it seems like the ball here. Okay, so the ball, you can see the magnitude is same, so means the speed is same. Okay, for velocity, you can see is the magnitude same, but it travel in different direction, right? So means the velocity is not same because velocity you have to consider the magnitude and also the direction if you want to call the velocity is same or not. Okay. All right. So before we move to the acceleration, okay. So let's summarize first what we have learned. Okay. So the first one we learn about is distance, right? Distance. Okay. So distance, if I have a triangle like this. Okay, so let's say A, B, C. Okay, so the distance, let's say this one is 6, 8. Okay, and then you use a theorem Pythagoras here. Okay, so you get this one is 10, right? So if I ask the distance from A to C, okay, so means 6 plus 8. Okay, 14. Okay, if I ask the displacement, okay, displacement, okay, for A and C, so that one should be 10 meter. Okay, all right. The next part is, they say if you want to find a velocity. Okay, so velocity is a displacement against time. Okay, so the displacement divide by time. Okay, so let's say the time here is 10 second. Okay, example. So means you have to use displacement, right? Velocity. So 10 divide by 10, you will get 1 ms speed. So speed, you have to use a distance. Okay, so a distance means divide by time 1.4 ms negative 1. Okay, so this is what you have learned. Okay, for ball, let's say A, and then this one is B. Okay, so m over s, this one is also 60 m over s. Okay, and then the question asks you, okay, whether the speed is same. Yes, speed is same because the magnitude is same. Okay, speed is same because the magnitude is same, because speed does not consider a direction. Okay, if velocity, then velocity is not same because of the direction. Because velocity is a vector, so vector you have to consider the magnitude and direction. Okay, so we can call, so velocity, okay, uniform velocity. Okay, the magnitude and the direction. Wait, not velocity. Wait. If you want to call it uniform speed, not velocity, okay? Uniform speed. Okay, for uniform speed, the magnitude either the direction. Okay, you don't have to consider the direction. Okay, only magnitude same, you can call it in the uniform speed. Okay, if the uniform velocity, direction should be same. This one you have to remember. Uniform speed, magnitude same. Okay, doesn't matter where's the direction, like this one, magnitude same. So this one is uniform speed. Yeah, A and B is uniform speed. Okay, uniform velocity, no, because they have a deal. No, this one. Okay, what is the difference? And then your friend asked about the whether the uniform speed is moving object, the object is moving or not. Okay, but let's say for, if you want to know whether the object is stationary, whether it's moving or not, if they use the word stationary. So this one stationary means the object is u is 0. Or v is 0. It depends. Okay, so this one you have to learn the question or learn like these terms. Okay, so we learn about this one today. So anything that you want teacher to explain again? I'm afraid like some of you will get confused already. Anything you want to ask teacher, please don't be quiet. Then if later when I ask you, you don't know how to answer. Anything you want to ask teacher? And if no response, I think all of you already understand
We'll take no
what you learned
questions.
today.
No
No.
questions.
Okay. So later, I think on next week, I will give you a short quiz. Okay, about all this, how to calculate this. So I want you make sure you get 80 above to show that you really understand what I teach. Okay. So make sure really understand this one. Okay. Fizik ni you tak boleh macam fikir kalau you tak faham sekarang. Benda ni akan bawa sampai you form 5 nanti. This is not normal. You didn't talk about PT3 anymore. We talk about your SPM now. Okay. So in time like this, we don't know what happened in the future. Okay. So this is what the best that I can do. So if anything you want me to help you, so please tell me. Okay. Ini bukannya macam PT3 kan, ini SPM, right? So you have to understand really. So teacher, for the speed graph, is distance against time, right? Okay, that one is actually 2.2, right? You already learned 2.2, motion of the graph. That one, yes. If distance against time, you want to find the velocity, you need to find the gradient. Okay, that one is 2.2. We are not going in 2.2 yet. Okay, we only learn about the term displacement, distance, velocity, speed. You have to know what is the difference between those four. Okay, alright. Okay, so on Monday we see how you whether you really understand or not. Okay, next we go to next part is acceleration. Okay, actually this one already learned in next, I think, right? You calculate the acceleration. Okay, you use the formula for acceleration. A is equals to V minus U divided by T, right? Sure you already see this formula before. Okay, alright. So what's the meaning of the acceleration? Okay, so acceleration is the rate of change of velocity. Okay, rate of change of velocity. Okay, and then this one, if you question ask you in the exam, this is what you have to give to the give answer. Okay, you have to give this one as the answer. Okay, acceleration is a change in velocity divided by time. Okay, so this is the formula. Okay, so V is what? V is a final velocity. U is what? U is the initial velocity. Okay, time is T. Okay, in second. So velocity, the unit is ms negative 1. This one also ms negative 1. And then the time is in second. Okay. Alright. So number 5. Okay, I let you try first. Okay, and then I will call one by one. So means there will be 4 person that will be called, okay, to answer these questions. Okay, so please try. Okay, use the formula here. I give you the formula here. V is a final velocity, U is the initial velocity, T is the time taken. Okay, and then after that for D, you need to just substitute all the value there and find the answer. Okay, for 4M, congratulations, good. Okay, all attend my class. If you have a problem, you can tell me. Okay, let's say you didn't attend my class. You have to text me, tell me the reason why you didn't come to my class. No need for me to text you. Okay, why you didn't join to my class? It's not because I want to be angry with you or not. I just want to know the reason. What is the reason? If teacher can help, I will help. Okay, I give you 2 minutes more before I ask anyone. Okay. Right, I call four of you. Okay, for A, Elvis. Elvis, for question A. For question A, Elvis. What's your answer, Elvis? Elvis, are you there? Elvis Cheong Z, cannot see your name full. Elvis? No, no response. Sleeping ah. Elvis?
Zero.
Zero. See, open your mic. Okay, so zero. Okay, good. Okay, because it says here bicyclists. Bicyclists. Okay, start from rest. So rest means is zero. The initial velocity is zero, and increases his velocity at constant rate until he reaches a speed of 4 meter per second in 5 seconds. Okay, so what is the final velocity? Next one is Kavanish. Kavanish. Kavanish, what is the final velocity? 0.8. 0.8. How do you get 0.8 for final velocity? Final velocity is 4 meter per second, right? Until he reach a speed of 4 meter per second. So means the final velocity is 4.0 m over s. Okay, right? Okay, the time taken is, alright, so next one is Ziying, Li Ziying, Li Ziying. Yes, what is the time here? What is the time taken here? What is the time taken here? 5, right? Very good. 5 seconds. Okay, so 5 seconds. Okay, next one, the last one is Lo Chi Seng. Yes, Lo Chi Seng. What's your answer? What is the acceleration? Lo Chi Seng. Sometimes you didn't come to my class, right? What's your answer? C or D? D. Calculate acceleration. C already answered. What is the acceleration here? D. Acceleration. Use this formula. Okay, later we explain again the whole questions. 8. Okay, let's see whether it's right or wrong. Okay. Okay, so Chiseng answer this one is 8 ms negative 2. Okay, so let's say the first question is say a bicyclist starts from rest and increases his velocity at a constant rate until he reaches a speed of 4 m over s in 5 seconds. So what is his average acceleration? So you can see here it start from rest. Means from rest, his initial velocity should be 0 because he's not moving. Okay, so initial velocity is 0. Then it increases his velocity at constant rate until he reach a speed of 4 meter per second. So means the 4 meter per second should be the final velocity. Okay, so 4.0 is the final velocity. Okay, and then it already give you the time taken. Okay, when you start change from 0 ms negative 1 to 4 ms negative 1, so it took 5 seconds to change the velocity. Okay, so t is 5 seconds. Okay, and then next one for the acceleration, you have to know and you have to use this formula. Okay, so v is 4, initial velocity is u. Okay, v is the final velocity. 4. Okay, initial velocity is 0 and the time is 5. So 4 divided by 5, you will get 0.8 ms negative 2. So the answer is actually 0.8, not 8. Okay, maybe you calculate it wrongly. Okay, 4 divided by 5 is 0.8. Okay, so for this question, anyone still didn't understand, you want teacher to explain again? Teacher, ms negative 1 or m over s, you mean like this one? Wait, like this, ms negative, this one, is it? Is it this one same? Alright, no. Okay, it's not same. Okay, this one if you put like, no, this is not same. It means this one is m over s, right? For this one is m over s. For this one is m over s negative 1. Okay, so this is wrong. Okay, so this is wrong. Okay, so it's not same. Okay, this one is the unit for what? How, right? Okay, where did you get this one? I also don't know. Okay, there's no such unit like this. Okay, only this one. Okay, all right, it's okay, you can ask, it's a good question. Okay, zero acceleration. Okay, so what does it mean by zero acceleration? Okay, so zero acceleration means the object move in a constant velocity. Okay, in constant velocity. Okay, so example, constant velocity. Okay, so that we call it as a zero acceleration. Example, let's say I said I drive my car with 60 kilometer per hour. Okay, in 1 hour. Okay, so means you can see here there is no change in velocity. I drive with the same magnitude, okay, same magnitude, and also must be same direction, right? Because this one is velocity. Okay, so you have to consider the magnitude and direction. So mean if I drive my car with 60 kilometer in 1 hour, so means this one the velocity is constant. Okay, so velocity constant means there is no change in velocity. Okay, so when there is no change in velocity means I drive with zero acceleration. Okay, so mean in 1 hour I drive 60 kilometer per hour. Okay, there is no change. Okay, not 65, suddenly 65, then suddenly I go 60 back, then it drop until 50 kilometer per hour. No. Okay, all the way for 1 hour I drive with the same magnitude, same direction, 60 kilometer per hour. So that's we call it as a zero acceleration. Okay, there is no change in velocity. Okay, so what if a constant acceleration? Okay, right, or you can say it's object at rest also. So object at rest, zero acceleration because the object is not moving, right? So means the acceleration is zero. Okay, okay, next one is a constant acceleration. Okay, so velocity increases at a constant rate. Okay, so example, when a car move at a constant acceleration of 5 meter 5 ms negative 1, its velocity increase by 5 meter per second for every second. Okay, so let's say the car move with a constant acceleration 5 meter 5 ms negative 2. Okay, right, so let's say I give you one example. Okay, I drive my car with constant acceleration. Okay, acceleration of 10 ms negative 2. Okay, so what does this mean? Okay, for every 1 second, okay, my velocity, my car velocity will increase 10 meter per second. Okay, so for 1 second, okay, my car velocity will increase 10 ms negative 1. Every 1 second it increase 10 ms negative 1. Then 1 second more increase again, what, 10 ms negative 1. Okay, that one we call it as a constant acceleration. Means the velocity increase with a constant rate. Every second 10 ms negative 1. 1 second ms negative 1. Another 1 second 10 ms negative 1 is increase the velocity. Okay, like this. So let's say let's say I start with 60. Okay, and then another 1 second it increase 70 kilometer per hour. And then another 10 second, another 1 second it increase 80 ms negative 1. Okay, and then another 1 second I increase 90 ms negative 1. Another 1 second I increase 10. So this is called as a constant acceleration. Means my velocity increase in the same value for every second. Are you clear about the zero acceleration and the constant acceleration? So ms is equals to, yes, correct, Junhin. M over S is equals to ms negative 1. Yes, sorry, I didn't see your question. Okay, so are you clear about the zero acceleration and constant acceleration? Clear. Okay, all right. Okay, so no homework for today, but there will be a quiz. Okay, chapter 1 and chapter 2.1. Okay, until what I teach today. Zero acceleration and constant acceleration. Okay, so we have a quiz on Monday. Okay, on Monday. We have a class on Monday. The next class, I think on Tuesday. I can't remember your timetable. Okay, but so the next class is quiz. Tuesday. Okay, thank you. All right, so on Tuesday we have a quiz. So please do a revision. Okay, so we see how you answer. It's a live question, a live session. Okay, So means you have to, I will see your marks. Okay. So take care class. Okay. Have a good weekend. Right. Thank you for joining my class. Right. If anything, you can text teacher. Bye.
So long and goodbye.
Bye.
Awa.
Hmm. For for